So far in Chapter 4, I've been telling you that there are only 4 ways to prove triangles are congruent. We've been using side, 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 angle, side, angle, angle, side, and angle, side, angle. And technically, I've been lying to you, but it was for your own good, because I didn't want you to make a mistake on this one unique example. If you look at the 2 right triangles that I've given you, and if I told you that this side of the triangle and this side of the triangle were congruent, and this second pair of sides on the 2 triangles were congruent, the question is, could you prove that these 2 triangles are congruent? Normally we would look at this and we would say, well, we have right angles that are congruent, so there's a pair of angles. We have one pair of sides marked congruent, so there's a pair of sides, and we have a second pair of sides marked congruent, so we have another pair of sides. Well, this is not one of the 4 theorems, so we couldn't say that these triangles were congruent. However, because the triangle has right angles in them, that means these triangles are right triangles. And that means I get another theorem that I could use, the Pythagorean theorem. So let's just pretend that this side was 3. Because it's congruent to the other triangle, this side also has to be 3. Let's pretend that this hypotenuse was 5, and if this was 5, this one would also have to be 5. Well, I could use the Pythagorean theorem, a squared plus b squared equals c squared, to figure out what this missing side of b actually is. So if a was 3, 3 squared plus b squared equals my hypotenuse 5 squared. That means 9 plus b squared equals 25, so b squared must equal 16, and b then is equal to 4. According to the Pythagorean theorem, it has to be. Well, if these 2 sides in the other triangle are also 3 and 5, according to the Pythagorean theorem, this has to be 4. So technically, I could mark these 2 sides the same, and then these 2 triangles are congruent by side, side, side. Well, what we just did actually is a proof of what we call the hypotenuse leg theorem. And the hypotenuse leg theorem is listed for you on your notes. If the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and leg of a second right triangle, then you can in fact say the 2 triangles are congruent, because we have more information about right triangles. So notice when we started, if I didn't have these numbers 3 and 5, I had one pair of legs on the right triangle, I had the hypotenuses that were congruent on the triangle, and I noticed the triangle was a right triangle. Those are the 3 things that I can use to say, you know what, I don't have to use side, side, side. I have the hypotenuse and legs of 2 right triangles, so they are congruent. So from here on out, we're going to use 5 possible theorems to prove triangles congruent. Everything else remains the same. So let's look at some examples of how we might use this. On example 1, let me mark the triangle this way. I'm going to give you a right angle, and I'm going to give you these 2 sides are congruent. Well, at first glance, I could mark the triangle for myself. I could say this right angle over here is going to be 90 because these are a linear pair. I could mark the reflexive side of the triangle that's being shared. And right off the bat, I see angle, side, side, angle, side, side. So I want to say no. But the hypotenuse leg theorem says if the triangles are angle, side, side, but it's a right triangle, well, this then is my hypotenuse and my hypotenuse. So I have those, and this shared side is a leg in both triangles. So I do have the hypotenuses congruent, I do have a set of legs congruent, and the triangle's a right triangle. That's exactly how HL works. I could tell you that those were congruent. Example number 2. If I give you right angles here, and then I tell you this side and this side are congruent. Take a second, decide, are the triangles congruent, and if so, which of the 5 ways to prove triangles would justify your statement? If you said hypotenuse leg, you're correct. Because when I look at this triangle, I see angle, side. I could mark the reflexive side that's being shared, angle, side, side, so I want to say no. But before I say no now on angle, side, side, I check. Are the angles right angles? Yes, they are. So this is a right triangle. I have a pair of legs, and this shared side actually is the hypotenuse of the triangles, so hypotenuse leg is going to work here as well. This is why it's so important that you know what the hypotenuse is and what the legs are, and we use that vocabulary correctly. Example number 3. I'm going to give you right angles in this corner and this corner. Same question. Are they congruent? And if they are, give me a reason that you would use to prove them congruent. On this example, I'm hoping you're saying no. They are not congruent. Because this time I have right angles, that's great. I could mark the reflexive side here, but I don't have either pair of legs. I don't know that these two sides are congruent, and I don't know that the top and bottom sides are congruent. And there are no theorems that are going to prove those two sides congruent for me, so I'm forced to say that these are not congruent. Now, you may be tempted to say, well, you've got alternate interior angles here and here, but alternate interior angles are only congruent if your lines are parallel. And I don't have any markings to say my lines are parallel. So be careful when you start marking alternate interior or corresponding, you must have those parallel lines. Example number 4. I'm going to give you an angle in this corner, and I'm going to give you an angle in this corner, and I'm going to give you these two sides. Are they congruent? Yes or no? Take 15 seconds to decide. Hopefully you said yes on this one, and let's make sure you said yes for the right reason. I'm hoping you marked this side as reflexive, congruent to itself, because it's being shared. So at first glance, it looks like an angle side side again. We know angle side side is not one of the 5 theorems. However, we look and see, is this a right triangle? Well, it looks like it, but it's not marked. So hypotenuse leg is not going to work here. I don't know if this side is a hypotenuse or not because the right angle is not marked for me here. So if this is an angle side side and hypotenuse leg doesn't work, why am I still saying yes for this particular triangle? Well, remember the theorem about isosceles triangles. If you have two angles in a triangle that are the same, now when I say that I mean in the same triangle. So hopefully you're looking at 3 triangles here. You've got the big triangle without the line down the center and then the 2 small ones. I'm going to draw a cross from those 2 angles and say, you know what? These 2 sides opposite those angles must also be congruent. So I could mark these 2 sides because I know the triangle is isosceles. Well, now I have options. If you said side, 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 you would be correct. And I want to see those markings on the triangle so I know that. Or if you marked these 2 sides and said side, angle, side, I would also accept that because you are having that relationship as well. Side, angle, side, side, angle, side. So depending on what reason you use, I want to see how you are marking the triangle. So please make sure you're doing that. Next example, number 5. You've got the right angles in there for you. I'm going to give you this side is congruent to this side, and this side is congruent to this side. Are these 2 triangles congruent? Yes, they are. And hopefully you're seeing this one a lot faster. There's nothing else I need to mark on the picture because I can see side, an angle, and a side, congruent to side, an angle, and a side. So this is going to be side, angle, side, and there's no arguing. Now you may be tempted to say this is hypotenuse leg because right away you see the right angle. Remember, hypotenuse leg is only used if it's an angle side side and then you have the right angle. Just because you have a right angle isn't going to make it hypotenuse leg. You still need to look for all possible combinations, and this one happens to be a side angle side. Last one, number 6. if I give you the right angle here, and then I give you two angles in the corners of that triangle, are the two triangles congruent? Yes or no? And give me a reason. I'm going to say yes, and my reason is going to be angle, angle, side. Because I'm going to mark this angle next to the 90 degree as 90 because that's a linear pair. I have angle, angle. I'm going to mark the reflexive side, so angle, angle, side. Now, is there other options? Yes, there are. If I hadn't marked the reflexive side, but I had decided to draw again across the triangle and mark the isosceles sides, if you were looking at the right angle and the side, this could be an angle-side-side relationship. But angle-side-side doesn't work, but since it's a right triangle, this is an example where I could also use hypotenuse leg. So variety of answers here again. Make sure when you mark the picture, I can follow which one justifies you saying the two triangles are congruent. Now, using hypotenuse leg in a proof. The best way that I can stress to remember this is when you use side, side, side in a proof, you have to list 1, 2, 3 pairs of sides in your proof to say side, side, side. If you use side, angle, side, you have to list 1, 2, 3 statements so you can say these sides, these angles, these sides. Angle, angle, side is the same way. 1, 2, 3, 2 pairs of angles and 1 pair of sides better be listed in your proof. Well, people look at hypotenuse leg and then thinking, oh, if I list the hypotenuse and I list the legs, I'm good. But every theorem requires you to list 3 things. Yes, you have to list the hypotenuse. Yes, you have to list the pair of legs that you're using congruent. But you got to remember, you don't have a hypotenuse and you don't have a leg unless you have a right triangle. So you need to tell whoever's reading your proof, oh, by the way, I'm using hypotenuse and legs because I have a right triangle. So let me show you how you would say that in your proof. In this proof, I'm trying to prove that triangle PRQ is congruent to PSQ. So I'm going to start just like we did examples 1 through 6. I'm just going to mark the picture with the information that I'm given. PR is perpendicular to QR. That means I'm going to get a right angle at that spot. PS is perpendicular to QS. That means I'm going to get a right angle. I'm also given that QR is congruent to QS. And then what I'm seeing is I have this reflexive side from Q to P. Well, that's an angle side-side relationship. However, the triangles are right triangles, so I could use hypotenuse leg for this. So my plan is to use hypotenuse leg. So when I start writing my proof, I need to list my given. PR is perpendicular to QR. PS is perpendicular to QS. And QR is congruent to QS. And that was all given to me. Statement number 2, I need to tell where I was getting these markings. QP I marked because it was reflexive and used in both triangles. So QP is congruent to itself because of the reflexive property. So you may be tempted to say hypotenuse leg right here because QR and QS, there's my legs, and QP congruent to QP, there's my hypotenuse. So you may be tempted to end the proof right here and say triangle PRQ congruent to PSQ because hypotenuse leg. But we're not ready for that because yes, we've listed the hypotenuses, yes, we've listed the legs, but we've never said we have a right triangle. So technically, all I've really listed is a pair of sides and a pair of sides. So I need to say, well, you know what? Angle S and angle R are right angles. And I marked those right angles on the picture because I was given perpendicular. And I know the definition of perpendicular says those will be right angles. Now I still haven't said that I have a right triangle. So my statement number 4 is going to be triangle PRQ and triangle PSQ are in fact right triangles. Now don't overthink this. How do I know just by looking at this that PRQ is a right triangle? Well, it's got a right angle in it. So I'm using the definition of what a right triangle is. So the definition of right triangle is my simple reason for saying they are right triangles. So now I've listed my 3 things. I've got that I have right triangles, which means this isn't just a side anymore, it's a hypotenuse. And this isn't just a side anymore, it's a leg. So I've got hypotenuses, legs, and right triangles. Now I'm ready to say in statement number 5 that triangle PRQ is in fact congruent to triangle PSQ because of the hypotenuse leg theorem. So just like all the others, I must list 3 things, and now I've proven that the triangles are congruent, so I'm finished. I would like to look at one more proof. Exact same picture, same starting information except for one statement. PQ is bisecting angle SPR. Look at the difference in this proof. If you start like normal by marking the picture, PR perpendicular to QR, PS perpendicular to QS, I'm still going to have this reflexive side. So right now I'm thinking hypotenuse leg because that's exactly what I had last time. I see the right angles. However, PQ bisecting angle SPR is different than having 2 sides the same. SPR is the big angle. Bisect means it's going to be cut equally into 2 parts. Now it doesn't mean it's going to cut angle Q down here. It just is going to cut angle SPR, the one that's listed. So looking at this, this actually is going to be an angle side and an angle side. So while at first it seemed like it was going to be another hypotenuse leg and it's the same picture, slightly changing given information is going to change my proof entirely. So I'm still going to list all the given information. PR is perpendicular to QR, PS is perpendicular to QS, and PQ is bisecting angle SPR. And all that was given to me. Now I'm going to say what I had on the triangle. I knew that angle SPQ was congruent to angle RPQ because that's what bisect means. So I was using the definition of bisect. And I've listed one pair of angles. I'm going to say that QP is congruent again to QP because it's reflexive to itself. And now I have listed one pair of sides. Now here again is where some of you jump too fast. We looked at the right angles and knew they were congruent, but we need to say that in our proof. So again I need to say angle S and angle R are right angles. And I know they're right angles because I know what perpendicular means. So that's the definition of perpendicular. Then in statement number 5, I can say angle S is congruent to angle R because I know that all right angles are congruent to each other. And there's my third statement giving me my second pair of angles. So number 6, I'm ready to say triangle PRQ is congruent to triangle PSQ because, not hypotenuse leg, but because I have an angle side relationship. So again, I want to caution you, be careful when you see right angles, don't start assuming hypotenuse leg. It could be any of the 5 theorems, but other than that, how we do the proof is going to stay exactly the same.